Hi everyone, in this video tutorial we will learn how to simulate reinforced concrete beam using Abaqus. We will going through all necessary steps for make our simulation successfully running, and also we will use reinforced steel for reinforcing our concrete beam. We will also use concrete plasticity damage material model for simulating our concrete beam. Let's get started. Let's first start with creating of our beam, concrete beam, create part, beam, solid extrusion, 3D deformable, continue, and let's sketch our section area of our beam, and we need to add dimensions to our sketch, 200 and 100 millimeter. Now let's create offset for this sketch. Click done, offset with 20 millimeter. Click done and click OK. Before going, let's save this sketch. Save as sketch one. Let, let's remove this sketch and click done. And now we need to add the length of our beam. Click OK. Now we have our beam part. Let's create our reinforcement rebar firstly by creating stirrup and also rebar. Let's create stirrup, stirrup, 3D deformable, wire. We need to select wire, click continue, and let's open the sketch one, save it before, and click done, and remove these lines. Click done. Now we have geometry of our stirrup. Let's create rebar part, 3D deformable wire planner, continue, and create our rebar with length equal to 2000 millimeter also as the length of beam. Click done. Now we have three parts: beam, stirrup, and rebar. Let's go to property module and create our material. Before that, let's go to import our material from library. We have library under name concrete 2, right? Let's import this material concrete. Dismiss. Let's edit and see the data and in this material density in the ton per millimeter cube, and also elastic Young modulus in megapascal, and concrete damage plasticity parameters, compressive behavior, tensile behavior, and also concrete damage in compression, and also concrete tension damage. Now let's go to create steel material for rebar and reinforcement. In the elastic property, all units and dimensions in megapascal and millimeter. Click OK. We have two materials. Now let's go to create sections. Section 1, section concrete. Solid, homogeneous, continue, select concrete material. Okay. Now for reinforcement with rebar and stirrup, we need to create beam section stirrup beam or trusses. We need to truss element for adding the section area of our stirrup element. Click continue. Now we need add material and section area of our stirrup equal to 78.1 millimeter in the millimeter power 2. Okay. Now let's create the second section for rebar with 12 millimeter in the diameter. Beam, truss, continue and select material and add the section area. Now let's go to assign each material section to their part. Create, select, click done and select section concrete. Click OK. Stirrup part, assign section, click done and now go to stirrup section and also rebar, go to assign section. Let's go to section rebar. Click OK. Now all parts have material. Let's go to assembly module and create our reinforcement for our concrete beam. Let's select stirrup and rebar, apply, and let's assembly these two parts. Let's rotate this part in the Y direction. Let's select part, click done, and select axis of rotation by selecting starting point and ending point of axis. First point, starting point of axis, ending point of axis, degree of rotation, angle of rotation. Click enter. Now we have the right direction of our rebar. Click OK. Let's move this rebar in the right position. Select part, select starting point, ending point, click OK. Now we need to add the second or the second and the third and the fourth rebar part in our reinforcement. Let's select rebar, first one, second one, we have four parts. Let's rotate all these parts. First one, axis of rotation, degree of rotation, okay, okay. Second part, axis of rotation, no. Now let's move these parts, this rebar in the right position with the stirrup. Click done, starting point, ending point, click OK. Select part, starting point, ending point, OK. Select part, enter starting point and ending point. You can add more rebar depending to your problem and your beam. It's okay for rebar, it's enough for our simulation. Now let's use this option, linear pattern, to create stirrup pattern in the direction of select instance to pattern, select direction, reverse direction, and add, and you can add the distance between stirrup and other 100. Now click OK. We have enough number of stirrup in our reinforcement. Now let's combine all these parts in single part. Go to merge cut instance, create reinforcement, merge geometry, remove or retain boundary intersection is normal. Click continue, select all parts and click done. Now in assembly module we have one part reinforcement. Now let's go to assembly with our beam, click apply. Let's move the beam in the right position or the stirrup in the right position. I think you need to move all parts in the 0 point. Let's select just the beam, move this point to the 0 point, click the enter. Now we have this in the right, in the position, in the 0 position. Now let's move reinforcement part in the right position for our concrete beam. Let's create point with 20 millimeter in the X and 20 millimeter in the Y. 20 and 20 and 0 in the Z direction. Now we have this point. Let's move our reinforcement in this point, starting point, ending point, click done. We have our reinforcement in the right position with our concrete beam. Now we have the right assembly of all parts in our model. Now let's go to create our step step 1, static general, continue, click enable our nonlinear geometry for nonlinear analysis for concrete beam, for concrete material. Okay, now let's go to step, file output, edit, and select the failure criteria of concrete, damage, compressive damage, and tensile damage of concrete. And also we need to see status for plasticity damage. Click OK. Now let's go to interaction module. The interaction we need in this step is the embedded region. Create constraint, embedded region, click continue. We need first select the embedded part, reinforcement, replace, select the embedded region, select wall part, reinforcement, click done, and select region, invert display, select beam concrete and click done. Now we have embedded interaction between reinforcement and concrete beam between these two parts. Let's go to part module for creating for make partitions in our beam to apply boundary condition. First, let's go to create datum plan with 3 points. First point, third point, third point. We need to select 3 points to create datum plan. The second datum plan, we don't need in the middle. First point, second, third, we have datum plan. Let's create offset datum plan from this flip direction onto okay 50 millimeter. First datum plan, second datum plan, we can select just the surface of our beam. Okay, we have two datum plan. Let's create partition of beam using datum plan. Select datum plan, create partition. Now we have first cell and the second cell. Let's create datum plan, create partition in these cell with this datum plan. Click done and select datum plan partitions. Now we have necessary partitions in our beam. Let's go to load module and apply boundary condition in our beam. First, let's go to boundary condition 1, initial step, symmetry, anti-symmetry, and cluster. Click continue. Let's select these two surfaces, support surfaces. Click done and pin it condition. Click OK. Now let's apply our load in our beam. Create load in initial step, mechanical load. You can apply concentrated force by inserting reference point and add coupling between top surface and these points, or add pressure or body force or any or gravity load. You can also add gravity load in our model by let's apply pressure, continue, select top surface of our beam, click done and apply your pressure in this surface. Let's apply 20 Pascal. Click OK. Now we have pressure in our beam. Let's go to mesh module and part meshing our parts beam 20 millimeter. Click OK. Mesh. Click yes. Let's go to assign type element. Click done and type element C3D 8R reduction element 8 node 3 dimension cubic, and also need to go to element deletion, yes, and max degradation 0.995. Click OK. Let's go to reinforcement, 20 millimeter size element mesh. But now let's go to assign element type, select wall reinforcement, and let's use not use beam element and use truss element. Truss T 3D 2 nodes. Click OK. OK. Now let's go to job and create our job. Create reinforcement beam. Continue. OK. Let's first check our model if we have any warning or any problem before submitting. Complete check. Let's continue. Click OK. Submit it. Now we have completed job, but before to go to the result, I made some changes in the load and decreased the load to 1 in the pressure, and also because the first is too big, and also change the mesh size to 25, I think, to 30 millimeter for minimizing the time of computing. Let's go to job and see our result. Now we have minus stresses in our beam. As you can see, we have stresses in the reinforcement still. Let's replace part instance reinforcement, replace. Now we have just the reinforcement of concrete beam, and the beam concrete. Let's see the damage, compressive damage, and also let's see our tension damage in our beam. That's all for this video. I hope you enjoy with this video. Don't forget to subscribe in my YouTube channel and make like for this video. See you in the next video.